Okay, the essential question for this lesson is how do you solve systems of equations using elimination? So we're going to start by going through the steps. We'll get those down, and then we'll use those to help us actually do some solving. And we'll do 3 examples, and then you'll have some practice at the end of the lesson. So first, when we're using elimination, the goal is to eliminate one of the variables by adding or subtracting right up front. Sometimes there's a little bit you have to do before you do that elimination piece, but you have to get one of your variables in both equations to be values that when you add or subtract the 2 equations together, it will cause them to cancel out when you're doing the adding and subtracting. So we want to eliminate one of the variables by adding or subtracting. Once you have eliminated one of the variables, that means you are only going to have one variable left in the equation, so now you can solve for that other variable. Okay, so eliminate a variable, solve for the variable. Then we will take the value that we found, plug it back into one of the original equations to find the value of the variable we eliminated originally. Okay, so by the time we're done with step 3, we will have both values for both variables. Okay, don't forget you're substituting in the original equation. And then write your final answer as an ordered pair. Okay, so very similar to the substitution. The substitution, you're plugging an entire expression into an equation where there's only one, so that you have only one variable in solving. With elimination, you just add or subtract the 2 equations so one of the variables cancel, and then you solve for your variables from there. Don't forget at the very end, always write your answer as an ordered pair. Now, here's a note. One of those things that you might have to do first before you eliminate that first variable is make sure that everything is lined up. You have to make sure all the x variables are lined up, all the y variables are lined up, all the equal signs are lined up, and your constants are lined up. We will do an example. Example number 3 is an example of where we will have to rearrange the equations so that everything is lined up before you start your adding and subtracting to eliminate. So let's do an example. So here's our first one. So when you're looking at these equations, you want to look at the 2 x variables and the 2 y variables and the coefficients of each of those. So in this case, if we look at the coefficients of the x variable, you'll notice one is a positive 3, one is a negative 3. And what happens with the positive 3 and negative 3 when you add them? Okay. They will cancel out. 3 plus negative 3 is 0. So this is 0. Then you add 4 plus 5, that gives you 9y. Then you add 8 plus 10, which gives you 18. We now only have one variable left. Solve for that value. So you get y is equal to 2. Now go back to one of your original equations so that you can find the x value. So I'm going to use 3x plus 4y equals 8. We've got our y value, so you're going to plug it into the y spot. So 3x plus 4 times that y value of 2 equals 8. So 3x plus 8 equals 8, minus your 8 from both sides. Get 3x equals 0. So divide by 3, that's 3 divided by 3, divide by 3, so your x value equals 0. So our answer is 0, 2. Make sure the x value goes first and the y value goes second. Now don't forget to check your solution, and when you check your solution, you have to check it in both equations. So we have 3x plus 4y equals 8. So 3 times the x value is 0, so we're going to plug the 0 in. 4 times the y value is 2, so plug in the 2. And then you're going to check to see if that works. So 3 times 0 is 0, 4 times 2 is 8, equal to 8. 0 plus 8 is 8, so we get 8 is equal to 8. So that one does work. Now let's try the negative 3x plus 5y equals 10. So negative 3 times x is 0. plus 5 times y is 2, equals 10. So negative 3 times 0 is 0, 5 times 2 is 10, and then add the 0 plus 10, so we get 10 is equal to 10. So it does work in both equations. Next example. We have 5x plus 6y equals 4, and 7x plus 6y equals 8. So if we look at the x's are different numbers. One is a 5, one is a 7. So we might have to do something with those. It's not quite as convenient as just adding or subtracting. So let's look at the y's and see if we can just add or subtract and cancel those out instead. So if you look at the y values, we've got a positive 6 and a positive 6. So at least the number in front is the same. So then what would you need to do so that those two would cancel when you combine? Okay, hopefully you're looking at, well, I can subtract those two equations, and then the 6's will cancel. 6 minus 6 is 0. So, but when you do it, you have to remember to subtract the whole equation. Don't forget this number at the end. So 5 minus 7, that's negative 2x. And be extra careful with your positives and negatives. Students leave those off a lot, and it will make a mess of the rest of the problem. So don't forget those positives and negatives. So we have 6y minus 6y, so that's now 0, equals 4 minus 8. So that's negative 4. Don't forget you're also subtracting that last value. Now we have x left, so solve for x. You get x is equal to 2. Now go back to one of your original equations. So I'll use the 5x plus 6y equals 4, and we're going to take the x equal to 2 and plug it into the x spot. So we get 5 times 2 plus 6y equals 4. So now we need to find the y value. So 10 plus 6y equals 4, minus the 10 on both sides of the equal sign. 6y equals negative 6. Divide both sides by 6. Y is equal to negative 1. Again, be careful with your positives and negatives. So your final answer here is 2, negative 1. Okay, a real quick check. We have 5x plus 6y equals 4. Our other equation is 7x plus 6y equals 8. And we're going to check that our value works. Remember, that's the x value, that's the y value, so we're going to plug them in. 5 times x, which is 2. 6 times y, which is negative 1. 5 times 2 is 10. 6 times negative 1 is negative 6. And so 10 plus a negative 6 is 4. 4 does equal 4, so that one works. 7 times 2 plus 6 times negative 1 equals 8. So 7 times 2 is 14. 6 times negative 1 is negative 6. So 14 minus 6 is 8. So 8 does equal 8. So it does work. That is our correct solution. We have one more example. Now note, in this example, the variables and equal signs are all over the place. Remember that last final note in the list. You have to make sure that you line everything up. So I'm going to rewrite the second equation. I think the first equation is in our standard form, 9x minus 3y equals 18. And then I need to rearrange the bottom equation so that I have my x's lined up, my y's lined up, and my constants lined up, and the equal signs lined up. When you rearrange, you have to use the same methods that we use when we're solving an equation to move things around. So I want the x to go on this side. To get it on that side, you have to do the opposite. Since it's minus or negative 7x, you're going to add 7x. It has to cancel out on the right before you can put it on the left. Make sure you're doing the same operation on both sides, adding 7x. So adding 7x, adding 7x. So then if I put these together on this side, I have 7x plus 3y equals, and then we have 30 left over on the other side. Now everything is all lined up. So, and you will notice that the y's a negative 3 and a positive 3. They're opposite values. So if you add them, they will cancel out. So 9 plus 7 is 16x. The 3 y's cancel, negative 3y and a positive 3y equals 48. Divide by 16 on both sides. You get x is equal to 3. Now we need to go back to one of the original equations to find the y value. I'm going to use this one. Again, notice I'm using the original equation, not what I changed it into. You must use the original equation. So we're going to take that x value and plug it into the x spot. 3y equals negative 7 times 3 plus 30. So 3y equals negative 21 plus 30. 3y equals 9. Divide by 3 on both sides. Y is 3. So your final solution is 3, 3. And our final check. Remember, when you check, you have to check in the original equation. So that's my first equation. And then this was my second equation. X and y are both valued at 3. X is 3, y is 3. We're going to plug them in. So we get 9 times 3 minus 3 times 3 equals 18. That's what we're checking. 9 times 3 is 27. Minus 3 times 3 is 9. And we're checking to see that that equals 18. If you go 27 minus 9, get 18. Does equal 18, so that one's good. This side, we have 3 times 3 equals negative 7 times 3 plus 30. So 3 times 3 is 9. Now, when you're working a problem like this one, you have to work the two sides separately. So I work the left-hand side. 3 times 3 is 9. You don't do anything else with that. You're going to leave it a 9 on that left-hand side. Then the right-hand side, you're going to work out separately. So you go negative 7 times 3, which is negative 21 plus 30. Then negative 21 plus 30 is 9. 9 does equal 9, so that one works. You have to work the two sides separately. So you do the left side all by itself and evaluate. Then you do the right side all by itself and evaluate. So now we're going to have some practice. So here are some practice problems. 1, 2, and 3 are very similar to your examples that we just did. Example 1, example 2, and example 3. And then I have a couple extras down here. They're short, but something interesting happens to those on number 4 and number 5. So try to solve those using the elimination and describe what happens in each of those cases. And then we'll discuss it in the next class.